everywhere data is getting collected, right? Lots and lots of data. So data science is not restricted to computer science basically, or to just coding, people who know coding. It is kind of something that you utilize data to improve something, right? To improve maybe a business, you provide better facilities to customers, better maybe customer service, make your company more customer eccentric, improve your businesses, improve your sales by pre-planning your, for example, inventory, right? If you are operating a retail store, you can pre-plan how much inventory do you want at this particular time, so that your sales can be maximized, your inventory cost can be reduced. If you talk about it can also be used in monitoring, for example, in manufacturing, right? Or mechanical people must be aware of this. They have, like in industry, in manufacturing units, a lot of defects and faults come and on a regular basis, and that really impacts the production line, right? The whole assembly line gets disturbed for that. So the data can in advance tell you that, look, this is something that where we are expected to get a fault, right? So we better prepare for something, maybe this part is missing, or some service engineers, or all those things. So all the data can be used to improve something, right? So I think to answer your question, that it is not just restricted to computer science. I think computer science guys has one plus point, that they know coding, right? But that is just something I think in today's world everyone knows, because if you don't, you can just open YouTube and there are tons of videos, and a code chef and all those programming websites are there. So I don't think that's a hindrance as far as data science is concerned. First, quickly, I will talk about the learning part, because there may be people who are new to this field and they want to know what is the exact learning path. So there are two ways. First of all, I will start with Python, right? If you know Python, Python is just like a tool which you can use or apply the concepts that you know about data science. So for example, if any statistics concepts is there, or you want to just sum up the sales of a company for all the transactions, right? You would need some programming knowledge to do that, right? Otherwise you'll need the calculator, or you'll do it on an Excel sheet. So Python is just like, like a tool which you can use to do or implement some concepts or solve some problem, right? But that's not it. It is just a starting. It is just a language barrier, and you can start with Python, right? Then you can go with statistics. If you talk about data science, like right now it's very buzz term in 2000, from 2012 onwards. But if you talk about 1980s, 1990s, there were no data scientists, right? There were statisticians. So data science has evolved from the statistics. So it becomes very important to understand about the data distributions, whether it's normal distribution or any other uniform distribution, or some of the hypothesis testing concepts. What is mean, median, mode, variance, covariance, correlation? So there are some concepts in statistics that get used a lot in data science. You don't have to read all the statistics books. That's not what I'm saying, but you should know enough statistics to go with it, right? Then once you complete the statistics in Python, it's your time to get your hands dirty on the real data, right? Because you know Python, you know statistics, so you can do the exploration. For example, you can check out some data, some sales data maybe, and you can check out how is the trends going, how the sales improving over time, or what are the different factors that are influencing the sale. For example, it's geography, or it's tier 1 or tier 2 city, or the population density of that area. There can be multiple factors that can impact the sales, right? So you can explore that in this phase of exploratory data analysis. Then once you begin doing exploration of the data, right, then next step is to learn how to do forecasting, how to do prediction. For example, using machine learning algorithms to predict something. For example, if there's a sales data, right, sales data of some industry, right, and you started to analyze that sales data. Now they want you to not just analyze the sales data, but also to predict what will be the future sales, right? We all have so far heard something about some prediction, like in Q2 the results would be this is the expected results, or Tata missed by 1% of their expected results. So all these news it's very obvious, right? You must have been hearing from long time right now. So that's all is done using machine learning algorithms, all sorts of forecasting, right? Then once you understand how machine learning works, right? The next step is the deep learning. Deep learning is just a part of machine learning where you use neural networks to make machines learn. So the why deep learning I have specially mentioned, because the accuracy or the results of deep learning is far more enhanced from machine learning. So just with a very basic example, if you were using, we all were using phones from 2008 2010, right? That was a time phone were in a lot of trend, right? 8 9 10. But there were a lot of phones that had speech recognition. We used to say something and it used to recognize what we are saying, but most of the time it was not very accurate. That's why people were not using it, but companies were giving these kind of features in their cell phones. That time this speech recognition was being done by machine learning algorithms, the traditional machine learning algorithms. But as the data got, a lot of data got collected over the time. Right now, as the computational power has improved a lot, right? The advancements of CPUs, GPUs, NVIDIA, all those things. Now, deep learning is being used, and you can see that whether it's Alexa, Google Assistant, Siri, right? They can do the speech recognition at a very lightning fast speed and a very great accuracy. So that thing is done by deep learning, right? So these are the 5 steps, and that can take you to the trophy of the learning path. Now, apart from this whole thing, you should be you should be active in your community. So that's another part of it, where you read blogs on towards data science or medium, right? You understand problems on Kaggle, you start contributing to that, or you try to uh, see what other people have done in the area. So there are lots and lots of problems on Kaggle. If you haven't visited, I would very recommend this thing to visit Kaggle and see what are the different problems. Then peer-to-peer interaction, like discussing in among your friends. So this is one of the greatest way I have experienced so far in learning and in analyzing things. So not everything you can soak in just by yourself. Since we all can interact each other from cell phones, from chats, from WhatsApp or discussion forums, Reddit, and all those things, you can take advantage of them and see what other people are thinking, right? Then watching videos on YouTube. If you know some concept is there, you don't know, anytime you can YouTube those concepts, and those lots and lots of good materials are available on YouTube. I also have a YouTube channel, so I will maybe share that in a while. And maybe you can start from Python playlist. If you are new, then you have statistics, EDA, all sorts of videos I have also added. If you want to go through that, you can check out. Then GitHub. Okay, once you start understanding things, GitHub is a very important point where you can actually contribute to the open source community, because a lot of these things you will be learning from the community. Then you should also be willing to share also. So that is the whole path that you can take to learn the data science or to be a data scientist. Now, coming back to what are the most focused area for industry perspective, people talk about people say that for industry, I know machine learning, I know data science, but for job I don't know where to focus more, right? And now where should you focus more is that from the data handling and feature engineering part, because most companies where they get stuck in the data handling itself, because these companies have huge and terabytes and petabytes of data, right? And to analyze such big data is a very, very challenging task. So when you're learning data science, spend your time wisely on data handling, data analysis, and feature engineering. This is very important step of feature engineering that people miss out, right? You can create some of the new features from existing data. For example, if I give you my date of birth, yeah, right? And there's some transaction details of mine and my date of birth is there. So you can conclude my age from the date of birth and see how age factor is impacting the sales of that company, right? For example, maybe 30 plus people are buying that particular product more, or maybe it's more oriented towards the youth, right? So they can get to analyze more things if you do feature engineering well, right? And this also, these new features you can add, they can also add to the prediction or machine learning models that I just talked about it. Now, data science processes. So data science process, if you want to know, it's very kind of simple. You collect the data from different sources. Let's say we want to do stock market analysis, right? We want to predict the prices of a stock. A lot of people get interested in how this is so cool. You can forecast the prices of stocks, right? But how can it be done? You can collect the data from different sources. Maybe you want to for Tata Motors, you want to predict, let's say, what would be the stock price tomorrow. So you collect maybe previous high, open, low, close of 5 years or 10 years. Then you collect some other data like economical indicators, or how the GDP has grown, how the overall automobile sector has grown in the year. So you collect the data from different sources. Once you collect the data, then you put the data in a very articulated way in those tables, right? The data is processed. You clean the data if there's something needs to be cleaned there or not. Maybe just very simple thing like you want to convert the date time format to some other format, right? You want to just have the month or year or something else, right? You analyze the data, how the trends, previous trends have been, or what were the different factors that has influenced the prices of Tata Motors. Was it when the economy was growing, how was it impacting the Tata Motors? Or when the overall automobile sector was going, did it impact the stock price? Or maybe so recently, I'll give you one very cool example. So if you a little bit on the background of stocks and all, Tata Motors stock has grown like 4 to 5, I guess 3 to 4 times from past 1 year or 1.5 year. Now the reason, like they were the early movers in this electrical vehicles, right? They were early movers. They have Tata Nexon EV, and in US, if you see, Tesla Motors stocks have also gone up significantly, right? That made the Elon Musk the world's richest man. So you can see some correlation, right? When the Tesla, which is also producing electric vehicles, stock is going so high, Tata Motors has stock soared to 2 to 3 times. So you can see some correlation between these two things, right? Electric vehicles is in trend, simple, right? So this all things you come to know when you do the EDA. Then once you do the EDA, you start building models and using the machine learning algorithms to do the forecasting. Then in typical business project, once the forecasting is done, you communicate, visualize the report, right? And also put that your whole forecasting model as a product, right? And then product can serve in the reality. You can deploy that in real time, which can give you real-time predictions for every day or every hour of the day, right? So that's a typical data science process. In portfolio, you should have your projects. That's one thing I told you, what kind of projects you should have, right? If you have some projects, you can share it to the open source. You can upload it on the GitHub, and the GitHub links you can put in your portfolio. Then you can have, if you have done solving some problems on Kaggle, a lot of companies now ask if you are doing Kaggle or not. I was doing Kaggle back in 2016-17. So I think that gave me a edge on interview in my Samsung interview, because that time it was not that much popular as it is. A lot of value. Then if you have some industry experience, some internship experience, it is good. If you attend college workshops, I think it is good. You can add that in your portfolio. Your contest ranking, so participating in contests on Kaggle, Analytics Vidya, Hacker Earth, all these things, or all these platforms organized like data science, machine learning platforms. So I think you can participate in them, get to prove yourself, establish yourself as a data science practitioner, right? And this all things add up to your portfolio. So that's about portfolio. Understand data, you get to understand the features, right? What describes a particular thing. And for example, we have here very simple apple. Apple can be described with its colors, right? With its type, with its shape, whether it's a logo or it's a fruit. It will be defined by the features that Apple has. That's how machine learning, or that's how the data science field works, right? And then we have two major things in machine learning, which are like supervised learning and unsupervised learning. And supervised learning needs annotated data, right? You should have the data. For example, these are all the features of Apple, and this is an apple or a red apple. These are all the features of an apple, but this is a particular logo. So this is annotated data. And in another scenario, you can have the data of maybe some animals, right? For a supervised learning example, for example, there's some animal who has 4 legs, who has a tail, right? And there's another animal who has like maybe 8 legs, doesn't have tail. So maybe it's a spider or it's a cat, right? So, but you don't know, you're not giving this information to the system. So what it will do, it will kind of cluster similar data points all together. Okay, two eyes, four legs, tails, come here, but it doesn't know, right? So there are two aspects to machine learning, which is supervised and unsupervised learning, and this you must know. You should start your journey from, if you are starting machine learning from new, start from very basics of supervised and unsupervised learning, because questions come from here, and you will also need them to solve some business problems.